Alright, what you're going to do is you're just going to fill in, follow along on the packet that you were given. Fill in the correct answers and try to understand it a little better, especially if you had any trouble with any of these problems on the test. So just make sure you follow along and doing what you need to do, trying to understand it a little better. Number one, and I'm going to go extremely quickly, so you have to make sure that you follow along. And any stray marks that fly up through off my pen, just ignore them. Number one says, ray AB divides angle CAD into two angles. So we got some ray, and that's what I'm talking about, these stray marks. We got some ray that comes through here, and it splits the angle into two angles. And it's ray AB, and we got angle CAD, so CAD. This is ray AB. Now it just tells us it splits it into two angles. It doesn't tell us that that it bisects it or anything else, so we can't assume that. So then it says, so ray AB is an angle bisector. Well, we don't know that because they didn't tell us that. And they want a counterexample. A counterexample is an example that shows that it's not true. Well, letter A says measure of angle CAB, that's this angle, is 20 degrees. Measure of angle DAB is 20 degrees, that's this angle. Well, that's not a counterexample because that shows that it does split the angle into two congruent angles. So if we look at the next one, if I draw another picture, same idea. Got our ray going up through there. Ray or angle CAB is 20 degrees. That's this angle. And speed this along. I'm probably not going to put those letters on there every time for every one of these. And then they tell us angle CAD. That's this angle, the whole thing, is 40. Well, if that's 40 and this is 20, that means this has to be 20. So then this would be an angle bisector. So again, that's not a counterexample. Letter C says angle C, the measure of angle CAB. CAB is this angle, is 70. And the measure of angle DAB, that's that angle, is 20. Well, then this would not be an angle bisector because it doesn't split it into two equal angles. So the answer there is letter C. That's a counterexample. Number two says, state the law of logic that is illustrated. We had two laws, law of detachment, law of syllogism. If you get an A on your math test, I'm just going to write this out in the shortened form. So if A, then you can choose where you go to dinner. Then you get to choose. And then the second sentence says, if you choose, you'll go to your favorite restaurant. So if choose, then favorite. Well, right away, you're given two complete sentences. Then this is using the law of syllogism. And the law of syllogism says, if this part, the conclusion of the first statement, and the hypothesis of the second statement are the same, then we can put these two together to make a new statement or draw a new conclusion that we know is true. So if you get an A, then you will go to your favorite restaurant. So we're using the law of syllogism, which is letter B. Number 3, if you miss class the day before a holiday break, then you will not get the bonus. So if you miss class, if miss then no bonus. Then it says you missed the class, or yeah, you missed class the day before Thanksgiving break. So it's just saying you missed. Well, the law of detachment says if we are given this first statement and it's all true, and we separate the hypothesis all by itself and it's true all alone, which they're telling us, then we can separate the conclusion all by itself and it has to be true. So what we can decide from this is that you get no bonus. And that's the law of detachment. Which was letter A. I'm probably not going to tell you the correct letter every problem, so just look at it and fill it in with the correct letter each time. Number four, they give us a picture. It looks like this. Again, my pictures won't always look spectacular. It says 3x plus 18, because I'm just rushing through this so you don't have to watch it so long. 5y plus 68. That's 5x plus 2. And 3y plus 96. So on this, we know that these two angles, this angle and this angle, add up to 180, but this has an x in it, that has a y in it, so that's going to make it a harder problem, so we probably don't want to do that. Well, we also know that this angle and this angle are vertical angles, so they have to be congruent, and they both have x's in it, so that's probably the equation I'm going to set up. 3x plus 18 has to equal 5x plus 2. Then we just solve it. Subtract 3x on both sides. End up with 18 equals 2x plus 2. Subtract 2 on both sides. You end up with 16 there equals 2x. Divide by 2. You end up with x equals 8. Then we could do the same thing for the y's. This angle and this angle are vertical angles, so they have to be congruent to each other. So 5y plus 68 has to equal 3y plus 96. That's a y. We'll subtract 3y on both sides. You end up with 2y plus 68 equals 96. That's an equal sign. Subtract 68 on both sides. You end up with 2y equals, if we borrow here, that's 8. 28, divide by 2, divide by 2. So you end up with y equals 14. So we got x is 8, y is 14. That should be one of the answers there. Fill it in. Number 5. Same kind of picture. We know this angle's 30 degrees. We know this is 4x plus 6. Same thing as we said on the last one. Then these two are vertical angles, so they have to be congruent. So 4x plus 6 has to equal 30. They just want us to find the value of x, so all we have to do is solve this. You end up with 4x equals 24. Divide by 4. You end up with x equals 6. That should be one of the answers on there. Number 6, they give you two walls that come together and they want to know which postulate is the diagram dealing with or suggesting. If you think about two walls in the room, they come together and we think of each wall as a plane. Well, those two planes come together and they intersect at a line. So two planes intersect at a line. And that should be one of the answers on there. Make sure you put the right letter out in the blank. Number seven, they give you two flags. Ignore that. They give you two flags. Well, they're sort of treating these two flags as a line here, and we know two lines intersect at a point. Two lines intersect at a point. So hopefully that's one of the answers on there. Number 8. They tell us segment CD is congruent to segment CD. Segment CD is congruent to segment CD. That's it's where we're saying anything equals itself. Well, that's a reflexive property. Reflexive property. And this time it's for segments. For segments. Because we were dealing with segments, or however they stated on there. So reflexive property, they state it as reflexive property of segment congruency. So it'd be letter C for number 8. Number 9, they tell us angle EFG is congruent to angle EFG. Same thing, except now we're not dealing with segments, now we're dealing with angles. So it'd be reflexive property of angle congruency. Reflexive property of angle congruency. So find that on there. That's letter A this time, I believe. Number 10. They tell you that angle B is congruent to angle C. Oops. Angle B is congruent to angle C, and angle C is congruent to angle D. And from that, we can decide, or we can conclude then that angle B has to be congruent to angle D. There's two different properties you could use here. We said that we were going to use substitution on something like this and just stay with substitution. But the other one that you could use is the transitive property. The transitive property. Hopefully that's one of the answers on there. The transitive property. Number 11 says, which statement, if any, about the diagram is true? So number 11, they give us a diagram that looks something like this. Again, my picture might not look the greatest. That's A, that's B, that's C, that's E. And they put these little arcs in here to tell us that these two angles are congruent to each other. The first one says angle ABE, that's this top angle here, and angle EBC, that's this bottom angle, are vertical angles. Vertical angles are like those angles right there. So those are not vertical angles, so A won't work. Letter B says ray BE is an angle bisector. To be an angle bisector, it has to split the angle to two congruent angles. So it does split it into two congruent angles, so B would be true. So, but we need to check the rest to see if any of the other answers are also correct. Points A, B, and C are collinear. A, B, and C. Collinear means on the same line. Well, those 3 points don't fall on the same line. Those 3 points make an angle, so they don't fall on the same line. And then D says none of these. Well, we already know that B works, so D can't be right either. Number 12. I'm going to use number 12. This is segment J. Let's just erase. Number 12, they give us a picture, it looks like this. And my picture might not look exactly like theirs. J, F, M, G, and H. And we just go through each thing. It says JM and MG are congruent segments. JM and MG are congruent segments. We don't know that, they didn't tell us, so we can't make that decision. B says angle FMG, that's his bottom angle down here. And angle HMG, that's that angle right there, are a linear pair. So these two angles, are they a linear pair? Yes, they are. So that one would be true. Now we'll check the others. Ray MJ and ray MH are opposite rays. MJ is right here, that's that ray going out that direction. MH is that ray going out that direction. Well, they're not opposite rays. Opposite rays would be like MJ and MG. So C is wrong. D says none of these. Well, we already know B is a correct answer, so D can't be right. 13. Decide whether inductive reasoning or deductive reasoning is being used to draw the conclusion. On 13 through 15, remember, inductive tells you a pattern. Inductive deals with patterns. Deductive deals with using facts or rules. So 13 says, all angles that measure between 0 and 90 degrees. Already, I know that we're using some kind of fact because we're talking about between 0 and 90 degrees. So we're probably using deductive reasoning. Let's finish reading it just to make sure. So when you get, I'm sorry, I was on the wrong one. I was doing 14. So let's see, 13 says, every day after school, your mom gives you a snack. So when you get home from school today, you will get a snack. Well, that's using patterns. You notice that every day after school, your mom gives you a snack. It's not any kind of rule or anything that she has to give you a snack. It's just some kind of pattern. So we're using inductive reasoning, and we know inductive reasoning deals with patterns. So if I look down through there, it'd be letter A. You'll notice that letter B also says inductive reasoning, but it says inductive reasoning using facts. Well, inductive reasoning doesn't use facts, so letter B can't be right. 14, now the one I tried to do earlier. All angles with measure 0 to 90 are acute angles. The measure of angle A is 56 degrees, then angle A is an acute angle. We're using facts there, so we're using deductive reasoning with facts, which would be letter D. Deductive reasoning with facts. Number 15, all numbers divided by or divisible by 6 are also divisible by 3. 36 is divisible by 6, so 36 is divisible by 3. On this one, I would accept one of two answers. I would accept if you said you're using facts, which would be deductive reasoning, which would be letter D, or since when we're dealing with numbers, it is sort of a pattern when you're dividing something by 6 or 3. So I would accept inductive reasoning using a pattern, which would be letter A. Number 16. 16, 17, and 18 just says write the negation of the statement. And I'm not going to write these down. You can figure it out and put in the correct letter. Number 16 says, it is sunny. Well, the negation of that just means to put not or make it sort of the opposite of what it is. So if the statement is, it is sunny, then the negation would be, it is not sunny. It is not sunny. 17, the cat does not have spots. On this one, it says the cat does not have spots. Well, then the negation of that would be that the cat has spots. The cat has spots. And then 18, the roads are the roads are not icy. The roads are not icy. Well, the negation of that would be that the roads are icy. The roads are icy. Problem 19 says use law of detachment to determine what you can conclude from the given information. They say if quadrilateral is a square, so if quad is square, and again, I'm just shortening this up to try to make it easier, ignore that straight line going across through there, then has four congruent sides. Then four congruent sides. Then they tell us that quad ABCD is a square. So they tell us something. This is using law of detachment. They tell us something using this, the hypothesis. So they're telling us that this is true all by itself. Then what we can decide is that the conclusion along with this statement is true all by itself. So quad ABCD has four congruent sides. We can say that quadrilateral ABCD has four congruent sides. So letter A says quadrilateral ABC has four congruent sides. That's what we're looking for. Number 20. You give us two lines and they intersect. And we got 2y plus 41, 6x plus 77, 4x plus 43, and 5y plus 48. Again, stuff that we know about this picture. We know that these two angles are a linear pair, so they'd have to add up to 180. But if I tried to add them up to 180, I'd have a y and an x in the same problem. I don't really want that. We know that these two angles are vertical angles, so they should be congruent, but again, that won't help us because we got a y and an x. So we'll try to come up with something else. Well, the thing that we can come up with is that these two angles are a linear pair, so they should add up to 180, and they just have x's in them, so that should be something that we can do. So 6x plus 77 plus 4x plus 43 should equal 180. We collect like terms, our equal sign's right there. We're not jumping over it, we're just putting these like terms together, so that's 10x. We got 77 here and 43 here. We're just going to add those together. That's 120, I believe, equals 180. Now we just solve it. Subtract 120 on both sides. End up with 10x equals 60. So x would have to equal 6. And then if we go back, we know that these two angles are also a linear pair. So 2y plus 41 plus 5y plus 48 should have to equal 180. That's 7y plus 89 equals 180. Subtract 89 on both sides. I'm going to run out of space there, so I'm going to move over here. 7y equals 180 minus 89 is 91. Divide both sides by 7. The 7's here cancel out. You're left with just y equals 7 will go into 91. Let's see, that's 13 times. So you got x equals 6 and y equals 13. Hopefully that's one of the answers there. Just make sure you put the correct answer out in the blank. Problem 21 says, if possible, use the law of syllogism to write a new conditional statement that follows from the pair of given statements. 21 says, if a figure is a square, so I'm just going to write this out real short. If you have a square, then it's a rectangle. So if it's a square, then it's a rectangle. Law of syllogism, they have to give you two complete sentences. If a figure is a rectangle, so if rectangle, then 4 right angles. Law of syllogism, with the law of syllogism, this part, the conclusion of the first statement, has to be the same as the hypothesis in the second statement, which it is here. And if that's the case, then we can put this hypothesis with this conclusion and still have a true statement. So a statement that we can come up with from that is, if we have a square, then you have 4 right angles. Hopefully that's one of the answers down there. If figure is a square, then it has 4 right angles. Figure out which one that is. Again, if it is a square, then it has 4 right angles. 22, they start off with this. That's shaded. Then they have this. That's shaded. Then they have this. That's shaded. That's shaded. And they want the next thing in the, they want you to sketch the next figure in the pattern. Well, this one had 1, this one had 2, this one had 3. So next one, I'm guessing, is going to have 4. And this one's going to be shaded, and this one's going to be shaded. That should be your answer. The rest of them, make sure you pay close attention to the rest of these. Your homework's going to deal with some of this, and it's going to be, you're going to get extra points added to your Chapter 2 test by getting that homework into me. And we'll talk more about that here in a minute. Next one says, write the converse, inverse, contrapositive, and tell whether each statement's true or false. And the statement this time is, if 2 angles are vertical. You can abbreviate a lot of this, but make sure you're not abbreviating so much that I can't understand it. Then they are congruent. The converse. Got to know these 3 things. The converse. All the converse does, it takes the hypothesis, which is that part right there, not the if, but the part with the if, and the conclusion, and it switches them. So the converse this time is going to say, if 2 angles, I know I didn't switch that, but I'm leaving the subject in the first part, are congruent, then they are vertical angles. So we just switched the 2 parts. And if 2 angles are congruent, that doesn't necessarily mean that they're vertical angles, so that would be a false statement. 2 angles can be congruent and not be drawn as vertical angles. The inverse. Inverse goes back to the original statement, and it negates both parts. So it puts not in both parts. So if 2 angles are not vertical, then not congruent. If you got two angles and they're not vertical to each other, that doesn't necessarily mean that they're not congruent to each other, so that's also false. Then the contrapositive. The contrapositive goes back to the original statement and it switches the two, so it switches the order, and it negates both parts, or puts not in both parts. So it's going to say if two angles are not congruent, then not vertical angles. And if we got two angles and they're not congruent to each other, well then they can't be vertical angles, because we had a theorem that said vertical angles must always be congruent, so that statement is true. So converse switches the hypothesis and the conclusion. Inverse negates the hypothesis and the conclusion. And contrapositive switches and negates. I'm just going to do 24 very quickly. The first one that they're asking us a reason for, it says BC equals BC. Well, they're the exact same segment, so the answer to that one is just anything equals itself. Anything equals itself. So that goes in the first blank. Then they have segment addition postulate as your reason for number 4. That was number 2. So for number 4, they have segment addition postulate. Well, if I look back up here and I have this segment, if I look at the next one, it says segment CD plus segment BC adds up to equal that whole segment right there, BD. Well, what we can do on this side over here is say that segment AB plus segment BC has to equal that whole thing right there, which is segment AC. And that is what goes in that blank. For number 4. Number 6 is your last statement. Well, your last statement has to be what you're trying to prove. If we just look back up at the problem, what we're trying to prove is that segment AC equals segment BD. So that's what goes in the blank. The last 3, these 2-column proofs. The first one's an algebraic proof, so I'm just going to do that real quick. This is number 25. Hopefully you remember how to solve problems from algebra last year. Your first statement is just going to be the equation they give you. So that was given. First thing we're going to do is we're going to use distributive property, distribute out here. And when we distribute out, you got to make sure you distribute out that negative also. Know that a negative times a negative gives you a positive. So the first one's going to be positive 12x. And then negative 4 times negative 9 is positive 36. And that still equals negative 12. And there we just use distributive property. Number 3, next thing we're going to do is we're going to subtract this 36 on both sides. When we subtract 36 on that side, there are 2 negatives, so we're just going to add them together. So it's going to be 12x equals negative 48. And there we use subtraction property of equality, because we did something to, but we did the same thing to both sides of the equal sign. Number 4, next we're going to divide both sides by 12. We end up with x equals -4. And there we use division property of equality. Twenty-six, they give us a rectangle, or what, I should say what looks like they give us a quadrilateral. Not sure if it's a rectangle yet, because I haven't looked at stuff yet. It says segment AB is perpendicular to segment BC. Well, if things are perpendicular, then we know they come together to form a right angle. So perpendicular tells us right angle. So somewhere in our 2-column proof we might say that. Then segment AD is perpendicular to segment DC. Same idea, so those two have to come together to form a right angle. So we're probably going to say that twice in our 2-column proof somewhere, that we have right angles there because of the perpendicular lines. Then, once we know that, we had a theorem that said if this is a right angle and this is a right angle, then they have to be congruent. So somewhere we're going to use that theorem to say this angle and this angle are congruent. And this one we can name just angle B, because that's the only angle that has its vertex at B. And we can name this one angle D to make it easier on ourselves, because that's the only one that has a vertex there at D. So we're going to use that theorem about right angles. And that's what we're trying to prove, so we should be able to go through and write this 2-column proof. Statements. A lot of you are writing something like this. AB plus BC equals a right angle. That doesn't work. We cannot add 2 segments together and end up with an angle. It doesn't work to add 2 segments together and end up with an angle. So don't do that. What we can say is that this is perpendicular to that, so they form a right angle. So the first thing I'm going to say is segment AB is perpendicular to segment BC. And we knew that because it was given to us. Once we knew that this and this were perpendicular, then we can say that this angle right here has to be a right angle. So I'm just going to name it angle B. We could have also named it angle ABC, but I'm just going to name it angle B to make it easier. So we know angle B is a right angle. And the reason for that is perpendicular lines, not perpendicular angles, perpendicular lines form right angles. That's an S. Perpendicular lines form right angles. Then we go on to the next given, and the next given said that segment AD was perpendicular to segment DC, and that was given to us. And same idea as in number 2. If this is perpendicular to that, then they got to come together to form a right angle. So angle D is a right angle. Same thing, same reason as number 2. Perpendicular lines form right angles. Now we look at this, we know angle B is a right angle, we know angle D is a right angle. We had a theorem that said that's a right angle and that's a right angle, then they have to be congruent. So I can say angle B is congruent to angle D, and that's what we were trying to prove. And our reason is that theorem, all right angles are congruent. Some of you went through and did it the long way, and that's fine. If you say that this is a right angle, then it's 90 degrees, and this is a right angle, so it's 90 degrees because all right angles are 90 degrees, and then use substitution to end up with angle B is congruent to angle D. That's fine. It just took longer. This is the shorter method to do it once we know that theorem. Next one, I'm not going to draw the mirror and all the extra stuff. I'm just going to draw what we have or what we need there. You know, this is angle 1, this is angle 2, that's angle 3, that's angle 4. And they tell us angle 1 is congruent to angle 4. And that's all the given information that they give us. Well, something that we know from this right away is that angle 1 and angle 2 are vertical angles, so they also have to be congruent, so I could mark it the same. We also know angle 3 and angle 4 are vertical angles, so they have to be congruent. The thing about this certain problem is we don't need to know anything about angle 3. They didn't really ask us. So we know angle 1 and angle 2 are congruent, so I'm going to write that down. And that's because they were vertical angles, and we had a theorem that said vertical angles must be congruent. Well, if we look right here, we know angle 1 is the same as angle 4. Angle 1 is also the same as angle 2. Well, that means that angle 2 and angle 4 have to be congruent by substitution property. And that's what we're trying to prove, is that angle 2 is congruent to angle 4. So we should be able to do this. Again, we didn't really need some of the information that we knew because we knew 3 and 4 were also the same, but we didn't really need it for this problem. Number 1, angle 1 is congruent to angle 4. That was given to us. Then number 2, we knew angle 1 was congruent to angle 2. And our reason for that was vertical angles are congruent. One of our theorems, vertical angles are always congruent. And again, we look here, we got angle 1 is the same as angle 4, angle 1 is the same as angle 2. That means these two have to be the same. So angle 2 has to be congruent to angle 4. And our reason there is substitution property. We just took out one thing and stuck something of equal value in its place. Substitution property. All right, you're going to turn the test in, what you were just writing on, you're going to turn it in before you leave. And then I'll tell you what the rest of the stuff that we're going to do is going to be.